Hi students, in this video we're going to look at how to calculate the sum of an arithmetic sequence. Alright, so after watching this video you should be able to recall the formula for the sum of the first n terms of an arithmetic sequence and then apply that formula to determine the sum of the first n terms of an arithmetic sequence. Now the key things you'll have to remember are the definition of our arithmetic sequence. So remember that there's a common difference between consecutive terms of an arithmetic sequence. Remember some of our notation. So T1 is our first term and D is our common difference. And just remember, when we use subscripts, that number in the subscript tells us the term number. So T for term, that number 12 means we're looking at the 12th term. You'll also have to remember our general form of an arithmetic sequence too, where T of n, where n can just be any number, is the first term plus 1 less than n times our common difference. Alright, now we want to consider this arithmetic sequence below. So we've got the numbers from 1 to 100. So it's an arithmetic sequence with our first term equaling 1 and our common difference equaling 1. And we want to find the sum of the first 100 terms, going from 1 to 100. Now I wonder how quickly you could do that one. It's actually not going to be too hard. I'll show you how we can do that in a minute. But to give you a head start, it's 5,050. And we can actually work that out pretty quickly by thinking about the problem a little bit. And then what we're going to do with that problem is create a formula. All right, so we've got our sequence here. And there's an interesting pattern that we can find when we look at the end terms, then the next two terms in, and the next two and next two, all the way through. So looking at these n2 terms, 1 and 100, if we add them together, that pair of numbers equals 101. Now, where it gets interesting is if we do the next two numbers in, 2 and 99, those numbers also add up to 101. If we keep going, 3 and 98 add up to 101. That's going to continue until we get to the very middle of our sequence. So all of the pairs on either end of our sequence, on either end of the numbers we're considering, they all add up to the same number, in this case 101. So T1, our first term plus our last term, equals 101, and that number is the same for all the other pairs as we work in towards the middle. Now the next question is, how many pairs do we have? Well, we have 100 numbers that we're looking at, and if we're splitting them into pairs, we're just going to divide it by 2, there's 2 for each pair, there will be 50 pairs total. So the total sum then of all 100 numbers, we've got 50 pairs, and those pairs all add up to 101. 50 times 101 is 5,050. And that's all there is to it. And this is the basis of our formula for the sum of an arithmetic sequence. We can add our first term and last term to get 101, and then times that by the number of pairs, which is just how many numbers are we considering, divided by 2. And this is what this formula tells us. So the sum of the first n terms of an arithmetic sequence is n over 2. So that's our number of pairs times T1 times Tn. Again, Tn is just the last term in our sequence. So this part here in brackets is just the sum of each pair, just like we saw in that example. And so this formula helps us work out the sum of our arithmetic sequence quite easily. Now, we can also make this formula a bit more general if we know what the common difference is by recalling that Tn equals T1 plus n minus 1d. That's our general form of our arithmetic sequence. So what we're saying here is that Tn can be written as T1 plus n minus 1d. So just substitute that in. And then what we notice next is we've got some like terms here. We've got 2 T1s written here as 2 T1s. And there's another way of expressing our equation, our formula for the sum of the first n terms. N over 2 is still there, that's our number of pairs, and this part in brackets, 2t plus 1 plus n minus 1d, that number also gives us the sum of each pair, but just written a little bit differently. So this second equation we might like to use if d is known. This first formula at the top here, it's useful if Tn is known. If we know what the last term is, we can sub everything in straight away. If we're not sure what that last term is, it's probably best to try and work out using this second form and either work out what d is, or hopefully we're told it. Right, let's use this in a couple of examples. All right, so let's do some examples. So we're going to consider an arithmetic sequence with a first term of 15 and a 12th term of 29. Sorry, first term of negative 15. Now we want to calculate the sum of the first 12 terms. Now notice here, if we want to find the sum of the first 12 terms, we're told what the 12th term is. So it makes sense to use our first formula, T1 plus Tn, because we know what the first and last terms of our sequence are. Because we just want the first 12 terms, and we know what the 12th term is. So the sum of the first 12 terms will be 12 over 2 times negative 15 plus 29. That's 6. 12 over 2 is 6 times 14 is negative 15 plus 29. 6 times 14 is 84. So the sum of the first 12 terms of this sequence is 84. Pretty straightforward one to start off. This next one will be a little bit trickier because in this case, we actually don't know what the 20th term is. Okay, we're not sure what it is. We could work it out, and that might be a way you would use to try and solve this problem. I would actually just rather use our other formula, Sn equals n over 2, 2t1 plus n minus 1d. So we know that n is going to be 20. We know our first term is negative 15. We just need to work out our d value. So our d value, we can work out from the information we've already been given. So we know T12 is going to be T1 plus 11D. That's just our general formula. To get from T1 to 12, we have to add 11 of our common differences. So substituting those values in, T12 is 29, that's negative 15 plus 11D, and into both sides that'll be 44 equals 11D, so D is going to equal 4. And now that I know D, T1 and N, we can just substitute into our formula. So S20 is going to be 20 over 2, 2 times negative 15, plus n minus 1, that's just 19, times our common difference, that's 4, 10, then in brackets that'll be negative 30, is 2 times negative 15, 19 times 4, 20 times 4 is 80, take away 4 is 76, so that'll be 10 times 46, which equals 460 as the sum of our first 20 terms. A little bit trickier, you have to work out D first, but still not overly challenging in this case. Alright, so after watching this video, you should be able to recall the formula for the sum of the first n terms of an arithmetic sequence, and also use that formula to calculate the sum of the first n terms of an arithmetic sequence.